Okay, third one. So differentiate the following three things. So I differentiate 3 sine 2x minus 5. Well, I'm going to leave 3 alone. Sine goes to cos, angle is the same, but times by the derivative of the angle, so you times by the 2, so that gives me 6 cos 2x minus 5. Now remember, I'm allowed to leave the 3 alone because it's a constant. If that was something like 3x, I would have to use the product rule. Okay, next one. ln 4 minus 3x. So ln differentiates to 1 over. Finally, times by the derivative of the bracket, which is minus 3. So again, minus 3 over 4 minus 3x. Or it's nice to write that as 3 over 3x minus 4. Just change the signs and everything. And the last one, differentiating sine to the power 6x. Well, you might want to actually use the chain rule for this one. So y, let's say u would be sine x. So y would be u6. Differentiate that. 6u5. Differentiate that, which is cos x. Times them together. So 6u5 cos x. Should have been what u was, which was sine. So 6 sine 5x cos x. The second one, we have f of x is ln x, and g of x is ln x4. Well, at the minute, it's not obvious what the transformation is, but if you remember, powers can go to the front. So 4 ln x. So g of x is just 4 times f of x. So that if it's a times, it's a stretch. If it's on the outside, it's y, and it stays the same. So the scale factor is 4. Yeah, remember you can sketch in your calculator, and that'll help you see it. Third one, solve e to the x plus 3 equals 4 to the e to minus x. Okay, do not use ln's. I can imagine some of you might think, right, well, if I do ln, I'll get x plus ln 3 is 4 minus x, or times minus x, whatever, 4 minus x minus 4x. However, we can't do that. If you want to use ln's, which mathematically is correct, but it's not going to help, you can do ln of this side equals ln of this side. However, there's no rule for having a plus inside an ln, so there's nothing I can do that left-hand side. So instead, we're going to be a bit clever. I'm going to write this as 4 over, because minus means over, e to the x. Now we've got e to the x and e to the x are the same thing. So I'm going to call that y and make a substitution, and hopefully we can spot where this is going. So we get y plus 3 is 4 over y, times that both sides by y. So y squared plus 3y is 4. Take the 4 over, and then solve that. Well, it's not a hard one to factorize. Just being lazy. 1, 3 minus 4. So we get y is 1, or y is minus 4. So back in what y is. So e to the x is 1, or e to the x is minus 4. That can't happen because e to the x is always positive. And then get rid of the e by doing ln on the other side. It's ln1, which is just 0. So my only answer is x is 0. Fourth one. So we have an arithmetic sequence starting 64, 62, 60, then etc. And we want how many terms until the sum is 0. So right up, you know, is 64, t is minus 2, and Sn we want to be 0. Okay, well, we have an Sn formula. So Sn is n over 2, 2 plus n minus 1d. So put everything into there. So 0 is n over 2, 2 times 8, 128, plus n minus 1 times d, well, d is minus 2. So I'm just going to times that 2 up. So 0 is n, 1 to 8, take away 2n plus 2, just expand that little bracket, simplify that. So 130, take away 2n. So then I either get n is 0, which does make sense, or this thing here is 0, which just means 2n is 130, so n is 65. And 65 terms in order for the sum to be 0. And then the last one, you've got that picture, so you've got 10 going this way, p going this way, where the angle is 30. And I said, given that the resultant vertical force is 20, so that means we split this up. Then this bit here is 20. So if you think about it, this bit here is the same as this bit here, and this bit here is adjacent, so that would be p cos 30. So p cos 30 must equal 20. So p is 20 over cos 30. Make sure in degrees now. If I'm in degrees, 20 over cos 30 gives me 43 over 3, or 23.1 to 3 significant figures.